I've spent 40 years trying to understand how the immune system works in terms of the interactions between these cells and antibodies, working out how it can actually learn from experience in a way that's good for the individual organism. It's all coming together. That's what's exciting at this stage. It's all coming together in a way at a level of completeness that we are now able to do experiments where we get the results that are precisely what we're looking for. And it's working. Since it's working, there's no stopping us now. We're able to actually manipulate the immune system in a way that is very beneficial to the organism. The theory has been slow in being developed. The theory has been developed over 40 years. And although important progress was made already at the beginning of those 40 years, there was a quantum step forward at that stage where some of the basic aspects of the theory came together. It has taken a much longer period to work out how this can be worked out or applied in detail. So we now are discovering, just in the last year in fact, we've made a lot of progress in seeing how to manipulate the system in a way that is actually beneficial. If we take the immune system of one person, we can change that immune system such that that immune system is compatible with the immune system of another person. By being compatible, I mean that you can do transplantation from person A to person B and from person B to person A without the need, potentially, of immunosuppressant drugs. We have some data showing that that's the case, some compelling data, in fact, that we can, for example, prolong the survival of skin grafts in mice that have been treated using our technology. And it's a significant prolongation. Whether we can get long-term survival of skin grafts and, in fact, seamless transplantation of organs without immunosuppressants remains to be determined definitively. But I have a high level of confidence that the type of adjustment that we're doing, where you're bringing two immune systems to be similar to each other, has application and will be effective in preventing certain degenerative diseases, in fact many degenerative diseases, including autoimmune diseases and cancer. That is where I have the highest level of confidence that we're on the right track. The brain and the immune system are both networks. We have neurons connected to each other in the brain, and in the immune system, the different clones of lymphocytes are connected to each other by interactions called VV interactions. That means between variable regions of antibodies, variable regions of lymphocytes, variable regions of molecules called specific T cell factors. Those interactions are important in the immune system, and we now have a handle on how those interactions work in the immune system. We understand that better than we understand how the brain works. After immunology, the brain will still be the big problem for budding theoretical biologists, and there's a good chance that budding theoretical biologists interested in the neural network will be able to learn from what we've learned about the immune network. The two systems are similar in so many different ways. There are about 15 different ways that you can list that say that the immune system is like the neural network in all of these ways. And in fact, when Yarner first formulated his immune network hypothesis, he emphasized the similarity between the brain and the immune system. And he felt that this similarity contributed to inspiring him with the idea that the immune system is a network. People trying to understand the brain should start by understanding the immune network theory, because I expect that that will be the best starting point to then try and understand the brain. I might be wrong. Obviously, they have a lot of dissimilarities as well. But my advice to a young theoretical biologist who wants to understand the brain is first understand the immune system. It's a big pie, and we have to simply find a way of dividing that pie between Network Immunology, Inc. and the big pharma company. Both we and the big pharma company, or small pharma, I mean, many companies of many different sizes could be playing a role here. Many other companies have expertise that we don't have, and the whole process can move ahead more quickly and effectively if we, for example, obtain investment capital from other companies as one way that would cement the relationship such that things can then move ahead efficiently and effectively.